Hi and welcome to this video about module enumeration. Now what do I mean by the term module? I mean in this case the simplest thing, which is DLLs or executable, or the executable itself, which is mapped into a process. So how can we enumerate and see which modules are loaded into the process address space? So here are three ways that are provided by the Windows API. One of them is the EnumProcessModules API, which we'll use. The other one is to use the ToolHelp API. And finally, we also can scan the address space. These are the ways that are provided by the Windows API in a kind of an official capacity. So let's see how these various ways work and their advantages and disadvantages. Okay, so here's my little project here. So I'm going to create three functions for these kinds of enumerations. And let's start with the first one. It's going to be EnumProcessModules. Let's call that EnumModules1. And in order to make it a bit easier to work with, I'm going to create a little structure here that's going to return a module info. The only thing I want here is a handle to a module, which is just the address into which this module is mapped into the process address space. So let's call that address, and some kind of name. Let's just have some kind of name, like the name of the DLL, for example. Very, very simple pieces of information, and would like to return a vector of these things from the various enumeration functions, and then we'll be able to call them. And once we do that, then we'll be able to display the information in main using the returned result. Just to make sure the compiler is going to be happy enough with these types, I'm going to include string and vector here, like so. So with that, we should be good enough in order to start working. Of course, I need to make sure I don't have any spelling mistakes. So in main, we're going to accept the process ID, which we'd like to use for enumeration purposes. The other thing to do is just to go ahead and do the work. So I'm going to just grab this parameter. So let's do that very quickly. If you don't have enough parameters, then the usage is going to be EnumModules with the process ID, and that would be it. Then we can return, and now we have the process ID. We can grab it. Let's use a simple D word here using the function str2ul. This allows us to grab the ID either as an integer with a decimal notation or with a hexadecimal notation, which is just might be more convenient in certain cases. So we have argv1 as our parameter. We don't care about where the actual parsing ends, and 0 here indicates that I would like the function to automatically figure out what the ID, the base is. So it's going to look for 0x as a prefix. If it finds it, it's going to assume hexadecimal. And now we're going to call here EnumModules1 and provide the process ID. I'm going to get back here the modules, and then we're just going to loop over these modules and display the information. So we can use this as a generic way to display the data we get back. So we have the address for the module and the name, like so. So we have the address, which is just some kind of address, and the name. So here goes, we have m.name. I'm going to do CSTR here to make the printing of a W string correctly, and we're done. So this is what we're going to have here as a baseline. So let's start with the first function, which is EnumProcessModules. So EnumProcessModules, in fact, is provided by the process status API header. So we need to add the psapi API here, header here, and we have EnumProcessModules. And you can see the first thing it requires is a handle to the process. So the first thing we need to do is to figure out how to get the handle to the process. And in this particular case, the handle to the process has to have the process query information access mask, but that's not enough. We also need the process VM read access mask. And the reason is that this function digs into the target process, into the process environment block, and grabs the information from there. So it needs this kind of access here. So if we can't get it, then obviously something went wrong, and we'll just return an empty vector here. And we can do something here in the case that we have an empty vector. We can assume there's some kind of error. So this is empty. You can say error. And of course we can display whatever get last error has to say, but it doesn't really matter that much for our purposes, because some processes are not going to be accessible, that's for sure. For example, protected processes will not be accessible from user mode regardless of whether I'm running with admin privileges or not. So if we have this handle working for us, then we can call EnumProcessModules. This is a fairly straightforward function. It requires the H process and then returns an array of H module object, which is just a bunch of addresses. So I'm going to just do things very simply here and assume that the process has no more than 1024 modules. Of course, we can call this function, allocate things dynamically based on returned value, indicating how many bytes we actually need, all that kind of stuff. But I'm going to leave that as an exercise for you, dear viewer, if you care about these things. For now, I'm going to keep it simple. So we have the size, which is the size of this array that I've allocated statically, and how many bytes we actually need. This is something we might want to use. So if the number perhaps is the same as the size of H module here, it means that we have exactly 1024 modules, or more likely there are more, and it just doesn't fit into the array. But in this case, I'm going to just stick with something very simple. If this returns something which is not 0, it means that it succeeded and we have these modules. So the only thing we need to do now is to iterate over these modules. So we have here, let's go with I, starting with 0, and then to actually how many we actually get, which is needed divided by the size of H module. That's the actual count, because the needed variable is returned with the size in bytes. We need the actual indices, how many of those that we have. So this is the number that we have. So now if I have this module info that I would like to fill in, the first thing I get is the address, and the address is exactly that H module. So that's easy. I just grab the address from the appropriate index in the array. The second thing is the module name itself, and it's not provided directly, but we can use other functions in the PSAPI API to get that information, like get module base name, for instance. Just for simplicity, that's going to be good enough for our purposes. So we're going to go and give it the handle to the process, the module itself, that is the address, which we can grab from here or from the module info variable. Then we get the actual result there and the size of the buffer. So I'm going to create a buffer here to call it name here, and just give it some big name, like 256 characters seems to be good enough. And then I'm going to provide name here, and the number of characters that we have is count of name, the number of characters that we have there. And so if this works, and we can, again, there's a return value here. If it returns a non-zero value, it means that we get a module name, and we can just go ahead and give it to the module info. And now we're just going to take our modules. We have to create a vector for this purpose. So let's go ahead and create the vector, module info, and just add it to the vector by using pushback and adding the variable into the vector. If you really want to be pedantic about it, you can do move, so you don't have to have some extra copy happening there. So regardless, once we're done, we can go ahead and close the handle to the process and return the modules array we have picked up. Okay, that should be good enough for first testing. So let's go ahead and open a command window here. I'm not going to run with the debugger in this case, just open a little command window. So here goes. We need some process to work with, and so I can take anything really. So we can start with something like explore. So we have the ID 2272, let's go with that. So we have enum modules, and we need to provide the process ID to 272. And you can see we get the list of all the modules in this process. In this case, we have lots of DLLs in Explorer. This is fairly common. And of course, we have the executable itself, which shows up as the first module here. And the second one is NTDLL. The third one is kernel 32. It's actually, it's going to be some kind of order, which is perhaps somewhat expected. Anyway, you can see the addresses here in the process address space into which each module has been loaded. And of course, we can try other processes as we see fit. For example, I have maybe find something like word. So I have WinWord here, 53988. Okay, so we can do that. So we have 53988. We get the list of modules in the word process. In this case, again, we expect winword.exe to be the first one, and ntdll is always going to be the second one, and so on. Now, what happens if we try something that is probably inaccessible, or definitely inaccessible in some cases? So, for instance, we can look at some protected processes like this is RSS thingy here. So we have 1096. And you can see we get an error, which is error number 5, which is exactly access denied, because we can't really get a handle powerful enough to CSRSS. Okay, now if you look at other tools such as Process Explorer, we can see similar things. If I go to Explorer, we can see that there's a bunch of modules here, but there are some other things here that are really mapped files, which are not truly modules in the sense that they're not PEs. Still, there are some kind of mapped files here that we see that are not true DLL, such as this kind of thing right here. It's just some kind of a mapped entity. And if I look at something like CSRSS, do I see the DLLs in CSRSS? Yes, I do in Process Explorer when you run it with admin privileges. And the reason is that Process Explorer has a kernel driver, and its kernel driver opens a handle with all possible powers, which would allow us to see any process with its modules. So it works because it has a kernel driver, and we are not using any kind of kernel driver here. Okay, so that was the first example. Let's take a look at another variant that we might want to use. Let's call that EnumModules 2, and we'll use the tool help APIs. The tool help APIs are very useful for enumeration purposes. In fact, we've used them in previous videos to enumerate processes and threads, but in fact, we can also enumerate modules in a process, in a particular process. So let's go ahead and do that. And the first thing we need to do is to get a handle to a snapshot. I'm going to call the function create tool help snapshot 32 something, and then we need to provide what we actually want to do. So in this case, we want to snap modules. We want to snap the modules in a particular process. This is where the process ID comes into play. We have to specify a particular process ID. We can't enumerate modules in the entire system. It doesn't work like that. So if this fails for whatever reason, in this case it returns -1 for this kind of case, I'm going to return an empty vector, again indicating something went wrong. And now we need to perform the enumeration. This is very similar to what we've seen when enumerating processes and threads. There is some kind of data structure, in this case called module entry. We need to make sure that the size of the structure is set up in the first member, which happens to be called in this case DW size. So we have that going for us, and then we can go ahead and perform the first call, which is module 32 first. I'm going to do that, provide the handle to the snapshot and the address of this ME thingy. And then we can look at what we get and extract the information from there. Before we do that, let's make sure we have a vector to work with. So let's create a module info vector here so we can work with that and return that thing at the end of our iteration. So we need to create a module info here. So the first thing we need is the address. So let's see if we get that. In ME, we're going to look at what we get here. We have a handle to a module, which means we do have the address. Just grab it as is. And then we need to have some kind of name. So let's hope we have some kind of name here we can work with. So there's these SZ exit path, there's SZ module. So let's go with module, see if it brings us something useful. And technically we're done. So it's very easy to use this API. I'm just going to do push back here. And again, for those that are C++ savvy, we're just going to do that to move this into the vector. And going to continue iterating while module 32 next returns true. So we have the snapshot here and ME. And now we're done. We can close the handle to the snapshot to be nice and return the modules array here. Okay, good. So now let's test it. And in order to test that, I'm going to just change here the call to EnumModules 2. So let's go back to our previous examples. Here's my Explorer. Let's just clear the screen here. So here's my Explorer example. So we have that. It works much the same way, as you can see. That was actually WinWord, that wasn't Explorer, so the Explorer is different, that's 2272 probably. So now we have Explorer as well, and that should work just as well. Here it goes, Explore. What about the protected process? Okay, so we can definitely try. So we have 1096, and you can see it doesn't work either. And so we're not allowed to peer inside protected processes. Even though we didn't open a handle to the process explicitly, we still are unable to do that. This is just part of life. For protected process, we can't access their internals from user mode with just user mode powers. Okay, so that was the second way of performing enumeration. How about a third way? So the third way, as we'll see, it's actually a bit more powerful. It's about using the APIs for enumerating memory blocks. So I'm going to create Enum module 3 here. And with that, we're going to use the function virtual query EX. But for that, we have to first open a handle to the process. So the first thing to do is open a handle to the process. We want to enumerate the address space of the process in question and just look at those parts in the address space which represent modules. So I'm going to ask here for process query information, which is what we need for virtual query EX to work for us. And so if we can't get that, then there's nothing to do, just return an empty vector. And virtual query EX allows us to enumerate an address space of a given process, in this case, the one being represented by H process. And we're going to provide an address. I'm going to start with an address here. Let's start with an address which is going to be 0. I'm going to start with address 0 or null, if you will. We're going to pass this address here. And every time we get some kind of chunk, we're going to continue enumerating. And the result is going to be something called memory basic information. This is a structure that provides the result of the information for a chunk of address space that has the same kind of properties. And then the size is going to be the size of MBI, not very difficult to work with. And this is going to be happening as long as it returns true. It will return false when we reach the end of the address space. So while we're doing that, we have to check each kind of block and see whether it actually represents some kind of module. And this can be done by looking at MBI dot, and we have some information here. The first thing is state. We need to make sure that the state is a mem commit, so meaning that there's some committed memory there, actual memory there. It's not a free region of address space and not a reserved region of address space. And since we're looking for specifically for modules, we need to look at the type here, and it should be something like mem mapped, something that is mapped into the process address space, not some random memory like the one you would get if you just call something like malloc, say. That's going to give you a different kind of memory. It's not a mapped memory, it's just a normal memory. It's what's known as private memory. So if you have both of this, it means there is some kind of thing mapped there. And if there is a file name around that, then this would allow us to actually get the file name information. So we can do that by calling get mapped file name. So get mapped file name says, okay, give me a process handle, give me an address within that process, which is the address that we have here as the address we're looking at here. That's actually address, or we can use MBI here with the allocation base. That's going to be the same thing. And then we can go get back the file name there. And if there is a file name, it means there's some kind of module being mapped there. Otherwise, it might be some mapped region which is not backed by any file name. In this case, we don't care in this particular case. So let's first make sure we have enough memory here to get the name of this module if it exists. And we have the size, which is again the number of characters that we have here in this name. And we need to make sure this returns something which is greater than 0. If this is the case, then we have a true mapped file here, and we can say that we actually have a module on our hands. Let's try that. We're going to have the address, which again can be provided by allocation base, if you will. And then we might need to do some casting here to make the compiler happy. Not very important, but still we have an H module here or whatever. It doesn't really matter. It's just a number, just a pointer. And then we have the name, which is exactly the name that we have here, and we can as before, push that into the vector. And of course, we have to define that vector before we begin. Like so. We have modules, and we're going to move to the next one. So to actually move to the next one, we have to take the address and move it forward by the region size. The region size that this particular instance of memory basic information describes. And then, and basically we're done. We just need to return the modules here. We might be also nice to close the handle to the process, but that's not super strict, crazy important in this particular little case. And now we can test that. Let's see if that works. I'm going to change this to EnumModules 3 and see if it behaves in a similar manner. So first, let's clear the screen. Okay, so I think I missed something. Instead of map image there, map actually need to use mem image. So I want to get true PEs. So let me do that first, and then we can test this out. So first, we're going to start with Explore. Let's see. And you can see lots and lots of stuff here, perhaps too much. We have some duplication here happening because we have different chunks that have different kinds of protection. And that's why we get lots of information here for modules that are actually the same one, it's just being described here in multiple addresses. And so what we can do for this purpose, we can do another check here. We need to grab and make sure that allocation base is in fact the same as the base address that we get here. So only in this case we are interested. Otherwise, it means that it's just yet another part of the same image we've seen already. That would be the simplest way to go about it, because the allocation base doesn't change and for the entire chunk of memory there. The base address changes internally for every kind of chunk which has different properties. So if we do that and try the same thing again, let's go ahead and clear the screen here, we can see that now we get every module just once. And it works in a similar way as we've seen previously. Again, in this case, there are two minor problems here, which you might notice very easily. The first one is that, well, we get a full path to the DLL or the module instead of just the simple name. And the second thing is that this path that we get is in fact in the anti-path way instead of the classic DOS path where we have drive letters. So I'm not going to show you how to make that conversion now. Instead, what I'm going to do, I'm going to just grab the name here, and I'm going to, instead of just taking the full name, I'm going to look out for the backslash by using WCSR-CHR to search from the end of the name and look for a backslash, and just grab the name from that location. So I'm just going to grab the simple name for simplicity here. So if we try this again, we now get the short names just as we've seen in the previous ways of enumerating. So what is the actual difference, or are there any significant differences between these enumeration styles in terms of the information that we get from these enumerations? So obviously, Virtual Query EX is richer in functionality. It can also enumerate things which are not necessarily images, could be some other mapped files, for example. So if I change that to mapped, or even if I just decide to go with anything except private, we'll be able to see certain things, which includes the PEs and also all the data files which are being mapped into the process, not as PEs, being just data files in most cases. So if I go ahead and try this again with Explore, we'll find that we have DLLs, but we might have other files as well. And so in this case, we see lots of DLLs, obviously, but you can also see other kinds of files, like this kind of file. This is just a mapped file. It's not an PE at all, in fact. All these DB files, these are just some database files used by Explore, whatever that format may be, but they're just being mapped as part of the address space of the process, so we can enumerate them with Virtual Query EX. The other mechanisms will not show that because they're targeting specifically modules that are PE modules and not just something being mapped into the process address space. there's another thing that that is kind of different a little bit in the way they work under the covers. And so, for example, one of the things I can do, I can hide the DLL in certain way. So I have here an application which is part of the course that we're currently working on and actually teaching at this point, which allows us to hide certain DLLs, from the address space of a process. And so I can do something like this. Well, actually, it's not really about hiding. It's actually about injecting DLL into a process. But what happens is that when we inject that DLL, it actually hides itself. So it hides itself. So as an example, let me launch some notepad here just to show that with a different process. So here's a notepad, and I'm going to go back to my original examination here. I'm going to enumerate the process of this notepad thing. So here's notepad 12516. So here goes 12516. And you'll notice that we have a list of DLLs here, and I'm not going to, and one DLL that is missing is simple DLL.dll. It's not really here. It's not shown up because I haven't injected it yet into the process, but I have here an example where I'm going to inject this DLL into the process. But as I inject that, the DLL also hides itself. And so when that would happen, we expect perhaps certain kinds of enumeration not to necessarily work out. And so as an example, I'm going to change that to do the same kind of thing, but work with multiple enumeration schemes. So we have the first enumeration scheme, and I'm going to just go ahead and do that little copy paste here. It's going to be pretty ugly, but still it's just to prove a point. And so let's do that a third time. I'm going to use the 3 ways of enumerating, like so, just to prove a point. So going back to this example, let me clear the screen here and do the enumeration again. And again, we have these 3 enumerations, which are going to show us very similar things. It's going to work out with the 3 types of enumerations. At least that's what we're supposed to be seeing here. And maybe to make it a bit more clear, let me make sure that we actually have some kind of space between them. So let's call that method 1. And that's going to be actually method 1 that's going to be here. So this method 1 is going to be method 2. And we're going to specify here method 3. So we have some kind of way to distinguish, to make it easier to see the results. So again, let's try this again. So here goes. We have here a method 3, and we have a method 2, and we have a method 1. And that particular DLL is not loaded anywhere into the notepad process, so we don't see here that DLL. But now let's go ahead and inject that into this process ID 12516. So here goes. It succeeded to inject that. At least that's what we get the report here. So now let's go ahead and clear the screen and run this again. And let's look for simple.dll. And let's see what we get. Let's go up and search. And we don't, well, it's not the right name. That's the right name. So you can see it here. It is in method 3. And do we see it again? No. As you can see, method 2 and method 1 don't show simple DLL at all. And so it is hidden from EnumProcessModules and the ToolHelp API, because the ToolHelp API actually works with the same kind of EnumProcessModules call. EnumProcessModules looks inside the PEB, and this is not there right now. It's just not there. I can prove that very easily by launching a debugger. Let me launch WinDebug here. So here goes. Let me attach to Notepad. Here's our Notepad. Let's attach to it. I'm going to just use the PEB command. With the PEB command, you'll notice that there's a list of DLLs here, and simple DLL is not here. Let me just look for simple. It's nowhere to be found. It's just not here. It doesn't exist. And so the PEB is where EnumProcessModules looks at in order to find the list of modules. But when using virtual query EX, we actually walking through the entire address space, so we have exactly everything that is in the address space. SimpleDLL is there, it's just not being visible there. Process Explorer, for instance, as another example, if you look for Notepad here and look for simple.dll, we'll see SimpleDLL, it is in fact here. So it does show up, and that's because Process Explorer uses Virtual Query EX to enumerate modules, and not something like EnumProcessModules or something like the Tool Help API. So Explorer does show the DLL, but other kinds of APIs will not show it. So these are the three options you have for enumerating modules using the standard documented Windows API.